3-1, solving system of equations. This lesson's all about all different ways to solve a system of equations. So let's go. First way is solve a system by graphing. So this is where we're going to graph both of these and then see where they cross. This way always works, just it's a little cumbersome. It would like draw perfectly. Same way, let's draw this one. So y-intercept is 4, so let's start at 4. And then my slope is 0.5, also known as 1/2. So I'm going to go up 1 over 2. I'm just going to do it a couple times. So I'm not going to be able to draw really nicely, so I'm just going to do this to help me out. As I said, I can't really draw nice on this thing. But anyway, there's that graph. And we're going to do the same thing with this one now. This one's not in the proper notation. So let's solve for y, divide by 3. And get y equals 4x over 3 minus 1. So in this case, we're going to start at -1, so my y-intercept. Then I'm going to go up 4 and right 1, use my slope. So 4, 1, 2, 3, 4. Right 3, 1, 2, 3. Up 4, 1, 2, 3, 4. Right 3, 1, 2, 3. So that's where they cross. Oof. There's my kind of straight line. And my solution is where they cross. Right there, which looks like 6 and 7. So that's the graphing method. It works, it's just you have to be very accurate to graph, and if they cross not at a nice point, then you're kind of screwed. So not the best way, but it does work. So that's solved by graphing. Now with that in mind, so we can see that they cross and we have a solution. Sometimes we graph and we have no solution. When they don't cross on the parallel, and sometimes we graph and they're actually the same line. So all those things have very specific names. That's what the next part is. So when we had right here, the one we just had, is where they cross. We call that an independent system because you have one solution. And those are also known as intersecting lines. So this happens when those slopes are different. If your slopes are different, you always have stuff that intersects. So call that independent. Consistent, independent. Consistent means you have a solution. So we just focus on the independent. So independent means you have only one solution. Now sometimes you draw and they're the same line. So no matter what you do, you're going to get an answer. That's infinitely many solutions. We call that a dependent system. No matter what, they're the same thing. So this is the exact same line. And then we have the ones where they don't cross. We call that inconsistent because we have no solution. Inconsistent. So that's when they don't cross at all. So they're parallel lines. They have no solution. So the easy way to tell this is when you have the same slope. Now same slope, but they can't be exactly the same. So they're going to have different y-intercepts. Just the same slope. So those three types of systems. We have independent when they cross once. We have dependent when they're the exact same line. We have inconsistent when they don't cross at all. So it's easy to tell when you graph which one is which, but what if I just give you an equation? Well, the easiest thing to do here is just put in slope-intercept form. So we put in slope-intercept form and they're the exact same line, then it's dependent. If they have the same slope, then it's inconsistent, and if their slopes are different, it's independent. So that's the easy way to tell. If I just give you an equation, if you want to figure it out, just put in slope-intercept form. So like right here, let me subtract the 4x from both sides. I get that. And then for this equation right here, we want to get y by itself, so divide by 3. And if you do that, you get y equals 8 over 3 minus 4x. So these are the same slope. So these are parallel, or also known as, we're talking about number of solutions, we have no solution, but inconsistent. That means they don't cross at all. No solution. Again, we can do the same thing with all these. I go right here and just put in slope-intercept form. Solve for y, so add the 2x both sides. Divide by -3. You get y is equal to -2x over 3 minus 3. Do the same thing with the next one. Subtract the 4x from both sides. Divide by 6. And y equals -2/3 x minus 3. Hey, they're the same line. So these are dependent. So they have infinitely many solutions. They're the exact same line. And you probably could guess by now this is going to be independent, but we can do it real quick. So let's solve for y. Negative 2y equals negative 9x plus 11 divided by 2. You get y equals negative 9x over 2 plus 11 over 2. If I do it for this one, 4y equals negative 5x plus 13. Divide by 4. Slopes are different. So these two are inconsistent. Sorry, or intersect. We call that, they do intersect, we call that independent. Independence, the proper name for that. Independent. So independent, dependent. Independent is one solution, they cross at one point. Dependent, they're the exact same line. And if they're parallel, they don't cross, we call that inconsistent. So those are the terms for that. Now let's talk about how to solve in alternate ways. The first way we solved was you graph them. This is the exact same equation we had at the very beginning. Right? Exact same equation. But now we're going to solve it by substitution. So the substitution method with that is generally you want to isolate a variable. And then you're going to sub that variable into the other equation. And we're going to solve. And don't forget to go back and once you solve, sub solution into original. Just plug it back in and get your answer. Just trying to say. Anyway, here look at, we got lucky. Y is by itself already. So what we're going to do is we're going to plug that in for the y right there. So instead of the y, we're going to plug all this in. So we're going to have 3.5x plus 4 equals 4x minus 3. Alright, substitution. You get a variable by itself, isolate it, and then you plug it in for that variable in another equation. Now we just solve. It's mathematics. You distribute, get 1.5x plus 12 equals 4x minus 3. Let's subtract the 1.5x from both sides. Add 3 to both sides. You get 15 equals 2.5x divided by 2.5. And you get x equals 6. 15 divided by 2.5 is 6. So we have our x, and what I was trying to say at the very end here was, hey, you're not done, you gotta find your y. So plug it back in. You can plug into any one you want. This is the easier one. But when you start off with, it's always the easier one. So 0.5 times 6 plus 4. Half of 6 is 3. 3 plus 4 is 7. So there you go. Y is 7, x is 6. We're going to write that as a point. And that's how you do substitution, right? You isolate a variable, plug it into that equation. So let's do another version of that. So here we go, right? Same type of idea. We're going to solve this by substitution. Now, again, the first step is always try to get a variable by itself. In this case, x is really easy to get by itself. So when we write this, we're going to add the 7y to both sides. X equals 7y plus 11. So we have that equation. Now what we want to do is plug that equation in for the x in this equation. So we're going to have 5 times, instead of x, we're going to have 7y plus 11 plus 4y equals negative 23. Right, we're plugging this in for the x right there. And again, after you do that, it's solving. Distribute 35y plus 55 plus 4y equals negative 23. Now, notice these y's are on the same side, so I'm just going to add them. Just simplify it. 39y plus 55 equals negative 23. Subtract 55 from both sides. 39y equals negative 78. Divide by 39. And y equals negative 2. But again, you're not done yet. You have your y, you do have to find your x. Plug it back in. Easiest thing to plug back into is this. So you get 7 times negative 2 plus 11. Negative 14 plus 11, so I get negative 3. So my answer is negative 3, negative 2. X goes before y. That's a substitution method. And that's going to my favorite method, the elimination method. So we're going to do the exact same problem we just did. Now we're going to do by elimination. Now the goal with elimination is you want to eliminate one of the variables. So like in this case, so you can multiply a whole row by a number, or both rows by numbers to eliminate a variable. So here's the thing, right? Let's get rid of this x to x's. I have a 5x on x. I'm gonna multiply this whole top row by a -5. Now I like to keep the signs different because then you just have to add and stuff cancels out. Some people subtract. I think it's wrong. It's bad. It's too easy to make a mistake that way. Just make them different signs. So multiply the top row by a negative. So I get -5x plus 35y. You gotta be careful you don't mess up signs. And -55. Right, so multiply the whole top row by -5. The whole top row, even after the equal sign. And then the bottom will keep the same for now. So that's just going to be 5x plus 4y equals -23. Add them up, these cancel. I get 39y equals -78. Divide by 39. And y equals -2. As always, we're not done. I have y, I gotta find x. Again, you can plug into sub it into any one of these you want. I'm gonna use the top one because it looks a little easier. So I have this. And now I know y is -2. So x minus 7 times -2 equals 11. X plus 14, double negatives, equals 11. Subtract 14. X equals -3. I write my answer as a little point. -3 and 2. Alright, so that's the elimination method. You multiply either one or both rows by a number to try to cancel stuff out. I always like to make them different signs. It distinct makes it easier. So that's one example. Let's do another one. So right here. Now in this case, it's not as easy, so I have to actually multiply both rows. Let's get rid of the a's because they're already different signs. That's gonna help me out. So if I want to cancel these out, I gotta find out what number they both go into, and that is 10 is the lowest common multiple of these two. So multiply 5 by 2 to make that a 10. I'm going to get 10a plus 30b equals -48. And then for the bottom one, I'm going to multiply that by 5. So I could cancel out for the whole row. And I get -10a minus 30b equals 140. Add them up, cancels, I get 0 on this side, and I get 92 on this side. So what happens here? All my variables cancel out. When the variables cancel out, you have two options. Option 1, you have a true statement. Which we do not have here. That's false. 0 does not equal 92. But if you have a true statement, then your solution is all real numbers. Option 2, we have a false statement. That's like what we have here. 0 does not equal 92. That's false. In that case, there is no solution. This is an inconsistent system. So no solution is my answer. So there you go. So anytime your variables cancel out, it's one of two options. It's either all real numbers or no solution. In this case, they all cancel out, so it's no solution. That's the general idea. So that's the three methods. We have elimination, which is my favorite. We have substitution, which always works. Like substitution, the way that works probably the most often, because there's sometimes you can't do elimination in the harder math, and there's graphing, which nobody really wants to do because it has to be so precise and doesn't always work out the best. Okay, let's do a couple application problems and we can just end this. So the first example here, first to the table at the right. Write an equation that represents the cost of printing digital photos at each lab. So we're going to print digital photos. We have online store. This is called Amazon. And that's 15 cents per photo and plus $2.70 shipping. So I got to make an equation out of that. Well, remember, we usually do this. Right, so per photo is going to be my m. So I get y equals 0.15 x plus 270 for shipping. Right, no matter how many photos I buy, it's going to be 270 for shipping. So that's that one. Then the local store, I don't know, Target, Walmart. I don't think Target does photos. So it's just 25 cents per photo. So there's no shipping costs. So it's just going to be y equals 0.25x. That is it. So those are my two equations. Under what conditions is the cost of digital prints the same? Both stores. So this one, it doesn't want me to graph. It just says, hey, when they're the same. So that's when they're going to equal each other. So just set them equal to each other, right? Substitution, plug this in for the y over there. So 0.25x equals 0.15x plus 27, 2.70 minus 0.15x. I get 0.1x equals 2.7 divided by 0.1. And just moves a decimal over and you get 27 over 1, so you just get 27. So when you buy about 27 photos, it doesn't matter where you get it from. Photos. When is it best to use easy online digital photos, and when is it best to use your local store? You can kind of look at this. I think this is the best one. This is the best to do by graphing. I like to visual aid this. Let's visualize. That was supposed to be black, but okay, whatever. Let's change it. There we go. So let's do Amazon first. So it's like, I'm just gonna do like a quick sketch, right? So 2.7 is my y-intercept, and then my slope is 0.15. So it's gonna be kind of like this. So that's Amazon. Now let's do the Walmart. It has a slope of 0. Well, it has a y-intercept of 0 and a slope of 0.25. So I can go a little faster. I know where they cross is 27 photos. So it looks like anything before 27 photos, you want to go to Walmart, the local store. Anything after 27 photos, you want to go to Amazon. Right, so there you go. Let's do one final, I should put examples up, sorry. This is the next one, same type of idea. Geraldine has a $10 coupon and a $15 discount coupon for her favorite store. The store has a policy that only one coupon may be used per purchase. When is the best to use Geraldine? When is the best for Geraldine? I'm not saying that right at all, I know. To use a $10 coupon, and was it best for her to use a $15 coupon? So kind of the same idea. So $10 coupon, we got to come up with an equation for that. So it's our price minus $10. There you go. That's your $10 coupon. That's how it works, right? Whatever the price is, subtract $10. 15% discount is a little different. So the best way to do that is actually this. You only get to keep, so if dress costs 100%, we talked about this earlier, you only get to keep 15% of it. As you don't pay 15% of it. So you're actually only paying 85% of the cost. So 0.85x. So that's the formula for that. So it's a little confusing, right? 50% discount means you only pay 85%. So 100% minus 15% we get off, we're paying 85 of the original cost. So when is it best for to use a 15 for use which one? Well, let's first see when they're the same. So I'm gonna set them equal to each other again. 0.5x is equal to x minus 10. There's like a 1. Let's subtract 1x. A little easier to see there. I get 0.15x equals negative 10 divided by 0.15. And I get x equals, I don't even know what that is. Let's use a calculator. It's an application problem. You can do that. I thought I turned it on. 10 divided by 0.15, about $67. So that's when they're both the same, right? They're both, it doesn't matter which one you use when it's about 67, the dress costs or whatever it is costs $67. When's the best to use each one? Well, draw a quick picture is actually off. Right, so that graph looks like this. This graph looks like this. So right here they're the same. So it's actually a little more complicated than normal, because I can't imagine they let you get a negative value on a dress. So I would say from here to here is when it's best to use the $10 off coupon. Every other time, it's best to use the 10%, the 15% discount, right? Because from right there, they're not gonna let you get negative $10. Anyway, that's that problem. Same idea. Last thing, let's talk about how to graph stuff on your calculator. How to solve by graphing. Now I'm gonna take away this equation because that's just an ugly equation. It doesn't really help. I'm just gonna make something up real quick. Let's go 2x plus y equals 10, and y equals let's see, plus 10, 3x minus 4. So I'm going to solve these two equations. So I'm going to show you how to do in the calculator. So bring my calculator again. So if I want to solve this, first thing I'm going to do is go to y equals. Now actually, a couple things I'll point out. If you notice there's a plot on right now, That's why it's dark. I'm going to turn that off. Easy way to turn it off is just highlight it, select enter. So notice that's not selected anymore, so my plot's not going to be on anymore. And that's when we did scatter plots. Second, I'm going to clear this one out. Now I want you to notice, these all say y equals. So this equation right here, I can't plug in yet. I got to get y by itself. So I got to solve for it. So subtract 2x from both sides. I get that. Now I can plug it in. So you have to get y by itself. So I can plug in negative 2x plus 10. And then for my second equation, I'll type in 3x minus 4. Then I'm going to hit graph. Now if you notice, my window is way off because I was doing little movie magic. I was doing the stat plot. I was doing the scatter plots a little while ago. So I got to fix my window. The easiest way to fix your window is to put zoom and standard. That gets you back to normal. So zoom standard gets you back to normal in negative 10, 10, 10. And you get a graph like that. I'm going to try and figure out where they cross right there. So what I'm going to do is I'm going to hit second calculate. And I'm going to look for intersect. That's where they intersect. Now it's going to ask you a question, what's the first curve? So if you move it around a bit, I'm on this curve right here. Yeah, just put enter. That's the first curve. Then we'll jump to another curve. If you move it around again, you see it's on this other curve. Yeah, it's the second curve, so you press enter. Then it says guess, and I'm like, yeah, of course I want you to guess. Why are you wasting my time? Hit enter again, and you get the answer, 2.8 and 4.4. And that's how you solve on the calculator. You put them in y equals form, you graph them, then you find intersection by going to second, calc, and then intersect. And there you go.